For the longest time, the world of AI felt like it belonged to the giants, defined by one thing, the heavy price of what they call frontier intelligence. But then, on March 18, 2026, a new signal cut right through all that noise, a disruptive protocol, and it changed the rules of the game. So let's break down what that signal is really telling us.
See, the thinking was always pretty simple. If you wanted the best, the absolute edge, you had to pay a frontier price. Power and cost, they were welded together. It was like a wall built around the future, designed to keep most people out.
And then this number shows up, 20.8, just a single data point that acted like a sledgehammer to that wall. This isn't a small change. This is the magnitude by which the old economics of intelligence were just shattered. So what does a 20x factor really mean when the rubber hits the road? Well, just look at the cost. For 1 million tokens of output, MiniMax M2.7 is going to run you $1.20. The big guy, Claude Opus 4.6, that's $25. Now listen, that isn't a discount. That's a whole new economic reality for anyone out there trying to build something new.
Okay, so you're probably thinking the same thing everyone else was. If it's that cheap, can it actually be any good? To get that answer, M2.7 was thrown right into the gauntlet, a series of brutal, real-world tests to see if the performance could even begin to match that price. First things first, you start with the hard stuff, code. On the SWE-Pro benchmark, which tests real-world software engineering, M2.7 hits 56.22%. Now that number is everything because it puts it right on par with GPT-5 codecs. Right away, it proves it can hang in a very, very demanding field.
But look, it's not just a tool for developers. What about the professional world? For everyday office tasks on the GDP Vol-AA benchmark, it pulled an ELO score of 1495. That makes it the highest scoring open source model out there. The thing's got range.
Of course, power doesn't mean a thing if you can't trust it. You're only as good as the truth in your output. And here, M2.7's hallucination rate came in at 34%. That's significantly lower than a competitor like Claude Sonnet 4.6, which sits at 46%. So it's not just powerful, it's more dependable.
And this is where the story goes from just being impressive to something truly revolutionary. Because you see, the performance of M2.7, it wasn't just trained into it. No, in a very real way, this model taught itself. It helped build itself.
How did it do it? Through this process right here, a recursive self-optimization loop. It would analyze its own mistakes, plan changes to its own code, modify it, run the tests, and then, all by itself, decide if the changes were good enough to keep. It ran this loop over 100 times. Now, just sit with that for a second. More than 100 rounds of autonomous self-improvement. That resulted in a 30% jump in its own performance, without a single human hand guiding the way.
This quote from the community really nails the importance of this moment. See, this isn't just another new model. This is a new way of making models. It's like a ghost in its own machine code, actively working to make itself better.
So you have to be asking, how in the world does it pull off this kind of performance at that cost? Well, the secret is in the architecture. It's a sparse mixture-of-experts model. Just think of it like this. You've got this massive library of 230 billion parameters holding all the knowledge, but for any one job, you only call on a small expert team of 10 billion. You get all the power, but for a tiny fraction of the cost.
All right, so let's bring all this theory down to the ground, because the main takeaway here is that this is not some experiment stuck in a lab. This is an arsenal ready to be handed to the people who are actually out there building things.
And it's ready to go right now. It just slots directly into the tools that developers are already using every single day. We're talking everything from coding assistants like Cursor to powerful platforms like OpenClaw. That means there's practically nothing stopping you from starting to build with it today.
Now, if you need one chart to ground all this in reality, this is it. In a head-to-head test, M2.7 delivered about 90% of the quality of Claude Opus 4.6 for just 7% of the cost. Now you just imagine explaining that trade-off to whoever holds the purse strings. That right there is a game changer.
But we gotta be real here. Progress is never a clean, straight line. It is crucial to see the whole picture. This is feedback from a real user who found the model inconsistent. It's a powerful reminder that benchmarks on a chart, they aren't the whole story. The signal isn't always perfect.
So when you put all these pieces on the table, the performance, the self-evolution, the real-world feedback, and especially that price, what does it all add up to? It means that the fundamental relationship between the cost of intelligence and the power you get, it's being redrawn right in front of our eyes. And this is the final, most important point. M2.7 isn't just a better deal on the old menu. It establishes what's called a new Pareto frontier. Basically, it's creating a whole new menu of what's possible. It proves that top-tier performance and radical low cost don't have to be enemies. And that means things that were once economically impossible are now suddenly on the table.
So there it is, a model that helped build itself, a model that rewrote the economic rulebook. The technology is here, and it's more accessible than it has ever been. So the only real question left for us to answer is, what will you build with it?